Hello friends, welcome to Get My Job channel. In today's video, we'll see top 10 questions asked for electrical engineer's job interview. Topic for today's video is transformer. So friends, prepare for the interview for the job of electrical engineer. Let us know top questions on transformers which are asked during electrical engineering job interview. To support your interview preparation, I'll be publishing series of the videos on each aspect of the electrical. To get such videos firsthand, please subscribe my channel and press the bell icon. So friends, let us see the typical question asked during electrical engineer's job interview. What is emergency release and what is the purpose of explosion vent pipe on the transformer? It is a large diameter explosion vent pipe fitted on the top of the tank of transformer projecting upwards and incorporating diaphragms on the mouth of it. If there is a large volume of gas formed within the tank due to short circuit fault in the winding, the pressure is released from the transformer through the explosion vent pipe by rupturing the diaphragms mounted on the mouth of it. Basically, it is a mechanical protection provided to protect the transformer tank. What do you understand by the efficiency of a transformer? The ordinary or commercial efficiency of transformer is defined as the ratio of output in watts to the input in watts. Since the efficiency is based on the power output in watts and not on volt ampere, the power factor plays an important role in determining the efficiency. Efficiency equal to output power upon input power. The formula is E2I2 into power factor upon E2I2 upon power factor plus losses. What is percentage impedance of transformer? The impedance voltage is the vector sum of resistance voltage and reactance voltage. The percentage impedance of is the value of impedance voltage expressed as percentage of rated voltage. Thus, percentage impedance or percentage impedance voltage is equal to V1 into Z1 dash upon V1 into 100, where I1 is rated primary current, Z1 is impedance with reference to the primary, and V1 is rated primary voltage. What do you mean by the expression given in nameplate of transformer, vector group dy11 and impedance voltage 5%? A transformer with vector group symbol dy11 means a transformer having primary winding delta connected and secondary winding star connected and belonging to the group -4 with plus 30 or minus 330 phase displacement between primary and secondary winding as referred to the standard counterclockwise vector rotation. Impedance voltage 5% means when 5% of normal voltage is applied across one winding, it produces normal full load current to flow through the secondary winding when its terminals are short circuited. What is the necessity of parallel operation? What are the combination conditions to be fulfilled before paralleling two or three phase transformers? To connect two or more transformers in parallel is called parallel operation of transformer. The purpose of paralleling is to share the increased demand of the load or to continue the supply in case of any fault and periodical maintenance to get maximum operational efficiency. The conditions for parallel operation of transformer are the voltage transformation ratio must be same. The polarity must be same. The percentage impedance should be the same. The phase sequence must be the same. The vector diagram and the phase displacement must be same. Why does a transformer require protection? What are the protective equipment required for a large transformer? A transformer requires protection for the following hazards: overloading and short circuit fault, internal fault, loose contact, short circuit between the adjacent turns, earth fault in the winding or leads, external hazards like lightning surges, and the system overvoltage. The protective equipments which are used for the transformer protection are buck-hose relay, overcurrent relay, differential relay, earth leakage relay, and lightning arrestor. What is the function of buck-hose relay? The function of buck-hose relay is to actuate an alarm in case of small amount of gas or trip the circuit breaker in case of excessive gas by making use of that gas liberated inside the transformer due to any internal fault. It also detects the accumulation of air on account of low oil level or faulty oil pumps. On transformer of rating 1000 kVA and above, the provision of gas pressure type protection with buck-hose relay is obligatory as per IEA rules. The buck-hose relay is installed in the pipe connecting the transformer tank and the oil conservator. What should be the angle of inclination of the connecting pipe of the buck-hose relay with the horizontal plane? What should be the size of the connecting pipe of the buck-hose relay? The angle of inclination of the axis of the pipe with the horizontal plane should be 10 degree or 11 degree. The nominal pipe bore diameter should be 25 mm for the transformers up to 1000 kVA, 50 mm for the transformer exceeding 1000 kVA but up to 10,000 kVA, and 80 mm for the transformer exceeding 10,000 kVA capacity. The length of the pipe of the lower section between the relay and transformer tank should be more than 5D, and that of upper section between the relay and conservator tank should be more than 3D, where D is the internal diameter of the connecting pipe. What is the lowest capacity of the transformers on which provision of differential protection is obligatory? On the transformer of capacity 10 MVA and above, the provision of differential protection against the incipient fault is obligatory as per IE rules. How are the earthing arrangements made for the following? 132 kV or 220 kV generator transformers, 11 kV or 33 kV substation transformers, 11 kV to 0.433 kV distribution transformer, transformer with the delta winding and instrument transformer. So let us see for the first 132 kV or 220 kV generator transformer. The metallic frame is earthed by two separate and distinct connections with earth. The neutral point is directly earthed by not less than two separate and distinct connections with the earth, each having on its own electrode, thus permitting the grading of insulation in the transformer from the terminal end to the neutral point. In case of 11 kV or 33 kV substation transformer, the frame is earthed by two separate earth electrodes as above, but the neutral earthing resistance earthing not less than two numbers may be used to limit the fault current which is expected too high in the case. For the 11 kV by 433 voltage distribution transformer, the frame is earthed by separate earth electrode and neutral of the secondary star winding is earthed by not less than two separate and distinct connections directly to earth having own electrode. For the transformer with the delta winding, the frame is earthed by two separate earth electrodes, and earthing transformer may be used to get star neutral point which may be earthed by two separate connections to the earth either directly or through a resistance if desired. In case of instrument transformer, cases or frames of instrument transformer, the secondary winding of CT and one point of the secondary winding of PT shall be earthed, which may be done by connection to the earth bus. What is tertiary winding? What are its functions? Tertiary winding is a delta connected additional auxiliary winding used with the three-phase star-star connected transformer which is wound on the same core and separated from primary and secondary or main winding. The function of tertiary winding is as follows. It prevents the oscillation of neutral point. That means stabilizes the neutrals of both primary and secondary winding by reducing third harmonic voltage components. It permits the transformation of unbalanced three-phase loads or single-phase loads only by limited voltage unbalance. It can supply an auxiliary load at low voltage, mainly for station loads. What is the maximum recommended spacing between the walls and the transformer periphery in case wall on the one side, wall on the two sides, wall on the three sides, and wall on all sides of an enclosed room? So, if it is a wall on one side, the spacing between wall and transformer periphery should be 0.5 meter. If the walls are on two sides, the distance should be 0.75 meter. If the walls are on three sides, then the distance should be 1 meter. And if the walls are on side, as in enclosed room, the distance should be 1.25 meters. What type of oil draining arrangement should be provided for a transformer having more than 2000 liters of oil? Oil soak pit filled with sand and gravel should be provided where oil capacity exceeds 2000 liters of oil. The capacity of the oil soak pit shall be such that to soak the entire oil content of the transformer. So friends, I hope this information was useful for you to prepare your electrical engineer's job interview questions on transformer. Please like and subscribe my channel for some more such videos. Thank you friends.